In Chapter 2, we're going to be studying trigonometry. We're going to build on some of the skills that you covered in Math 9, including the Pythagorean theorem and solving problems using similar polygons and also solving problems involving ratios. Some of the big ideas in this chapter is going to be a right triangle, ratio of two sides within a right triangle, and we're going to use those ratios to find angles and side lengths within a right triangle. Before we start, we have to get some important terminology understood. And first of all, the correct labeling of a right triangle. We use capital letters when we label the vertices of a right triangle. And the sides across from each vertice are labeled with a lowercase letter. So side A is across from angle A, side B is across from angle B, and side C is across from angle C. We also have to refer to three sides of a right triangle as opposite, adjacent, and hypotenuse. And these are with respect to one of the acute angles. So for example, if we look at this acute angle here, the hypotenuse is always across from the right angle. The opposite side would be the side opposite the given angle. So this would be considered the opposite. And this side here would be considered the adjacent. So we have hypotenuse, opposite, and adjacent. Now, if we change this to the acute angle, notice the hypotenuse will not change, but now the opposite side is going to be this side down here, and the adjacent side to the acute angle would be this side here. So the opposite and adjacent can change depending on which acute angle you choose. Now, for right triangles, there are different relationships between the sides and the angles, and we're going to explore all three of these in this chapter. And the first one we're going to deal with is section 2.1 is going to be the tangent ratio. Now, the tangent ratio, if angle A is an acute angle in a right triangle, then the tangent of angle A is the length of the side opposite angle A divided by the length of the side adjacent to angle A. So quite often we'll see tan theta is equal to opposite divided by adjacent. All right, in this example, we want to determine the tan D ratio and the tan F ratio. So again, tan of any angle is opposite over adjacent. So to find the tan of angle D, here's angle D. The opposite side of D is 3, the adjacent side is 4. To figure out the tan of angle F, now there's my angle. The opposite side is 4. The adjacent side would be 3. So again, opposite and adjacent will change depending on which acute angle you choose. Okay, I want you to pause the video and I want you to give this one a try. Okay, again, hopefully you've had a chance to solve this question. Again, tangent, remember, is opposite over the adjacent. So to figure out tan ratio for x, the tan of x, here's angle x, would be opposite, which is 6 divided by 12. To figure out the tan of angle z, it would be opposite, which is 12, divided by the adjacent, which is 6. All right, now we're going to use the tan ratio to help us find the size of an angle within a triangle. Now, if we were solving a mathematical equation, for example, if we had something like 3x is equal to 6, the process of the mathematical application between 3 and x is, or operation, sorry, is multiplication. So to undo this multiplication, we would divide both sides by 3 to get x equals 2. Well, very similar when we are dealing with an angle, say we want to find the size of an angle if we're told that the tan ratio of that angle theta, and we just use theta as a symbol for an angle, is say 3 over 4. Well, to undo the left side of this equation and to get theta by itself, we would do what's called the tan inverse of each side, which is sometimes referred to as arctan. Now, when I take the tan inverse of tan theta, these really cancel out, and I'm left with the angle theta would be tan inverse of 3 divided by 4. And you would punch this into your calculator to come up with that answer. So that's the process we're going to use when we look at these next few examples. So notice the wording in this question. Now, we're not just looking for the tan ratio, we're looking for the measures of angle G and angle J. So to find the measure of angle G, I'm going to start with angle G. And again, I have to start with the tan ratio for G. So tan of G is going to be opposite 4 over 5. And now to get angle G by itself, I must take the tan inverse of both sides. And now tan inverse tan cancels out, so I'm left with G is equal to tan inverse of 4 divided by 5. And now, depending on your calculator, you have to figure out how to calculate the tan inverse. First of all, make sure the mode of your calculator is in degrees. And quite often on your calculator, you might have to go shift tan or second tan and 4 divided by 5. And if you do it correctly, you should get an answer to the nearest tenth of 38.7 degrees. Okay, now some of the older calculators, you'll have to type in 4 divided by 5 first and then go second tan, but you might want to pause the video here and try to figure out how your calculator works to get the correct answer. Again, make sure you use a degree symbol in your final answer, because if you don't use a degree symbol, there's another unit for degree for angles, which is called radians, and if you don't have a unit, it's assumed to be radians. All right, I want you to pause the video and give this question a try. Oh, let's go back here. Sorry, we forgot to figure out angle J. Got a little excited there. So again, to figure out angle J, they're going to say that the tan of angle J is going to equal opposite over hypotenuse, which in this case would be 5 divided by 4. Again, we're going to take the tan inverse of both sides. And again, tan inverse tan cancels, so angle J is going to be the tan inverse of 5/4. So tan inverse of 5 divided by 4. So J is going to be 51.3 degrees. All right, now I want you to pause the video and try this next example on your own. Okay, I'm hoping you had a chance to try these questions. And again, we're looking for the measure of these angles, not just the tan ratio. So again, to start with, I'm going to start with angle K. And I'm going to say the tan of K is equal to 9 over 13. And after we've done a couple of these, when we take tan inverse now of both sides, we know that tan inverse tan will cancel out on the left-hand side. And we'll just be left with tan inverse of 9 over 13 on the right. So second tan, 9 divided by 13, that's going to be 34.7 degrees. Now to find the measure of angle N, I'm going to start with the tan of angle N is opposite, which is 13 over 9. And again, if I take the tan inverse of both sides, I will end up with tan inverse of 13 over 9. And this angle N is going to work out to be 55.3 degrees. Okay, so we know how in the first couple of examples to find the tan ratio, and now we can extend that concept to find the measure of the angles by taking the tan inverse of both sides, or the arctan of both sides. Okay, a little bit of terminology. Angle of inclination, which is sometimes referred to as the angle of incline, or is always defined with the horizontal. So if we take a look here, this would be the horizontal, and the rooftop angle of incline would be this angle with its horizontal. So in this question, we're asked to determine the angle of incline to the nearest degree for triangle ABC. Again, they're not giving you which angle the incline is, but by definition, it's the one with the horizontal. So we're really looking for the size of angle C. And I know the side opposite C and the side adjacent to C. So therefore, the tan of angle C is going to be 410 divided by 1700. Therefore, I'm going to take the tan inverse of both sides because I'm trying to find the size of the angle. And now I'm going to go second tan, or tan inverse of 410 divided by 1700. And angle C works out to be, to the nearest degree, approximately 14 degrees. So again, same process. The only difference in this question is we have to find the angle of incline. So we have to indicate on the triangle or find that first, which angle we're trying to find. Okay, so that ends the first part of section 2.1, the tangent ratio. Those are the few questions you can try from your textbook. And if you have any, if you want to check the answers, remember the answers are posted on the web page for all those questions.